In part 4, it's all about patching. I introduce some basic and generally important patching rules, as well as the underlying voltages and their meaning for our patching activities, followed by showing and explaining a bunch of basic patches. Part 5 may well be called the Patch University, as I introduce and analyze more than only a couple of quite advanced patching techniques with the Volca Modular. In part 6, I show you how to integrate the Volca Modular in the Eurorack world, and I really mean integrate, not just using it parallel with your Eurorack setup. The matter of alternative power supplies, not only for one Volca and not only for Volcas at all, finishes this series. On one hand, I have to make my living from producing things like this here, and on the other hand, I want you all to make profit from what I had to learn on my own. That's a dilemma. I try to solve it like this. All 6 parts are produced, they are finished, but I'll upload them one after the other, waiting always 3 weeks before I'll publish the next one. And if you'd like to get them all now and at once and support my work, please donate $9. The donate link is down in the descriptions. I'll send you the download links to all 6 parts then. Thank you for supporting my work. First of all, I want to know which version of the firmware is installed with my Volca Modular here. And to find out, I switch the machine off at first. Then I press and hold the record button here and switch the machine on again. And the LED in the space unit here will start, or should start, blinking, as well as the memory button, this one. And the most important thing, the LEDs below the keys will show the firmware, or should show the version of the firmware. I expect either the LED below key number 4 or number 5 or number 8 to blink, corresponding to a version 1.04, 1.05 or 1.08 at Korg's website, as Korg's website tells me. Well, let me try. I'll switch the light off to make the LEDs better visible, kind of light show. Okay. Pressing and holding the record button and switching the thing on. All right. One thing I see already, which is a little bit surprising, 2 LEDs below the key. The keys are blinking. Let me switch the light on again. I hope it made a nice picture. So, yeah, and the active step, the play button is blinking, a thing which isn't written on Korg's website either. So I think I've got something like version 1.59 or something, but definitely not 1.08. So I'll have to update the firmware. Well, let me proceed with doing so. There is a nice description. I hope this is at least 100% correspondence to reality. There's a nice description at the website of Korg. All right. I go to Korg's support page, where I find that the most up-to-date version of the firmware is version 1.0.8. I knew it already. And the previous version was number 1.0.5. So it seems to be the version which is loaded, which is active in my Volca Modular. After downloading and extracting everything, I'm ready to start the update process. The tension grows. Following the instructions that came with the download, I use a stereo mini jack audio cable here. You can see it, I hope, to connect my computer's audio output to the Volca's sync-in input. So I do so. Then I press and hold. The machine is switched off at the moment. Now you see no light. Then I press and hold the memory button this time and the play button, these two. Press and hold them and switch the machine on. The memory button and the function button should light. Yes, they do, indicating that they are ready to receive the update data. And I should start the playback of the update file, what I'm going to do now. So, but nothing happens. The LEDs below the keys should indicate the status of the update process, which is supposed to last about 4 minutes. Perhaps I should increase the volume with my computer. So I stop the whole thing and start the procedure again. All right. So, memory and play button, switching on. Memory and function button are lit, and I start again the sound file, which should update my machine. Now the sound file is running. Ah, yes, here we see something. So I can imagine when all LEDs are lit, the process will have finished, and Korg tells at its website, at their website, that the update is successful when all 4 buttons, the play, record, memory, and function, will lit. It goes quite fast. I let the camera and the voice recorder run, even if 4 minutes waiting and watching only LEDs blinking may be a little bit boring, but it seems to go fast. I have not stopped the time, so I can't tell you right now, at least, not yet, whether it's indeed about 4 minutes or not. 15. Last round. 16. And now I'm curious whether and all 4 knobs are lit. Then I can and should switch off the machine. Okay, according to Korg's website, I'll do so. Remove the audio cable here. And now the big moment, the great moment, perhaps better, has come, trying to find out the new version of the firmware. So, what will I do? The same as before, pressing and holding the record button and switching the machine on. Yeah, and indeed it's 8 now, and again this 9, whatever it may mean, but I'm up to date now with the firmware of the machine. Okay, great. So we can proceed with our investigation of and in the Volca Modular now. The first thing to find out when starting with patching semi-modular synths is the exact way they are pre-patched under the hood, and the second question is, how do they react when activating a patch point by inserting a patch cable. Second question first. The pre-patched structure is not interrupted when inserting only one end of a patch cable, and the pre-patched connection between an output and an input is not interrupted when patching the output to the input of another not pre-patched module. But the pre-patched connection between an output and an input is interrupted and replaced by the patched signal flow when I patch another than the pre-patched module to an input. Let me show this. The audio output of the source module is pre-patched to the audio input of the left LPG, as I will show later, plugging in just one end of a patch cable, either in the carrier output of the source. Just a moment. Of the source module, nor putting only one end of the patch cable in the input of the LPG module doesn't change anything. Neither does patching the carrier output of the source module to the signal input of the left LPG. Put it in. All right. And even patching the source module's output to the space module doesn't change the fact that the carrier signal is still connected to the left LPG as well. The patch to prove that looks a bit complicated. Let me set it up and explain step by step therefore. So I patch at first the carrier output directly to the input of the space unit. And by doing so, I lead the signal at once there without the need of a gate impulse, a gate signal at the LPG and without the LPG. But still, the signal is still connected to the LPG as well. So, what do? I take the output of the LPG. And connect it to the input of the split unit. I do the same with the output of the source unit. Fiddly, yeah. Come on. So, and now I take the output of the split and put it into the space unit. And you see, both the filtered signal, I have the cutoff frequency completely to 100% up. And now I reduce the cutoff in the gate. And what remains is the direct signal from the source unit. So both signals are, both signal paths are active in this patch. The one directly, across the simple split unit to the space out, as well as the one to the left LPG and from there to the space unit. Now the signal is only from the direct signal, unfiltered, and when I open the filter and the gate, I have both signals. I can mix them, so there's a more elegant way to mix it, but this is only for demonstrational uses. But when I patch the modulator output, so not the carrier output, but the modulator output of the source module to the input of the left LPG, then the connection is interrupted. We hear only the modulator and not the carrier, the main output of the source module anymore. So at first as it is, without patching. Let me remove the reverb. So, and now I take the modulator output and put it to the input, and now we hear only the modulator. Carrier, modulator. All in all, we can say that patching an input interrupts, but patching an output doubles the signal and sends it into two directions, the internal pre-patched one and the one I patch it to above the surface of the machine. But take care, all the aforesaid is valid only concerning connections between different modules or between modules, not concerning patching inside a module, namely patching, for example, inside the source module. When I patch the carrier output of the source module into the pitch input of the source module, I lose the clean carrier signal. Nothing is doubled. Well, let me do it. And now I take this carrier signal and patch it to the pitch input. So it's now self-modulating. The carrier is modulating, frequency modulating itself. By the way, quite nice sounds we can gain. Okay, let me do it. So now we can say the influence, or I can hear the influence of the modulation amount knob is active, of course, but when I put the modulation completely down, I don't hear the clean, I leave it away, I don't hear the clean carrier signal, the clean carrier sound, which I would if the rule an input and by patching an output doubles would be valid even in between or inside this module, this single module, the source module. Once again, patching from here to somewhere else doubles the output. The internal link patched structure is sustained, whereas patching from here back into the same module, then I change the pre-patched structure. All right. Well, at last it's time to look at this ominous pre-patched structure under the hood and to do it very in detail. The macro structure is simply standard. There are two control voltages being sent at each keystroke at the keyboard or each step of the sequencer. The pitch CV, which goes to the sound generator, the source module, and the gate signal, which initiates the start of the envelope of the left function generator. The source module generates an audio signal according to the pitch CV it has got from the keyboard or the sequencer, and sends this audio signal, this sound, to the low-pass gate module. At the same time, the level CV generated by the envelope generator arrives at the LPG and opens and closes it again according to the adjusted envelope. The LPG sends the audio signal ahead to the space out module, from where it reaches our headphones or other external devices. The Woggle module is not part of the signal flow, but of the standard signal flow, but is pre-patched to receive an audio signal, the sample source, from an internal noise unit. So far, the default structure without any further details about the modules. Things get a bit more interesting and sophisticated when we take a look at the internal structure of the participating modules, though. Let's discuss them now one by one, therefore. The source module first. Looking at the structure of the source module, we discover quite easily why we didn't get a clean carrier signal when we fed the carrier output back to the pitch input and turned the modulation strength completely down. There is simply no attenuator in the feedback loop. The knob to regulate the modulation strength is part of another signal path. But let me go through this module step by step. I'd like to start with the modulator circuit. This part of the source module receives two input signals, one of which determining the pitch of the carrier, the other the strength, the amplitude of its output. The strength of each of these two signals is the sum of the offset value set by the knobs, plus an additionally arriving signal at the inputs. The output of the modulator reaches the pitch input of the carrier then, where it adds to a signal which eventually arrives at the pitch input, From there, the audio signal is sent through the wave folder and then to the carrier output. The strength of the wave folder results from the sum of the fold offset knob and an eventually arriving signal at the input. As we already know, the modulator has an audio output of its own, which the ratio offset knob as well as the pitch input jack do have influence on, but the modulation amount knob, what is nothing else than the volume of the modulator's output, does not have any influence on. The two function generators are quite a bit more easy to understand. The basic difference to the source module concerning patching is the fact that they need an external signal to do anything at all. They need a gate signal, the left generator, or a trigger signal, the right generator. Whereas the left generator, the one which is part of the default pre-patched signal flow, needs a level high signal at its gate input all the time to be active. The right function generator, the attack release one, doesn't care about that. It's perfectly happy with the short impulse, does its work after getting one, and falls asleep again, even if the level at its input is still a high. Let me demonstrate that. I feed the output of the AR generator, here the output, to the level input of the left LPG. And I feed the output of the gate signal from the keyboard. Let's say this one. Here, just a moment. Red cable. So here is the output of the gate into the trigger input of the AR generator. All right. Now I touch a key and rest my finger there. And even if the whole time the gate is high, the tone doesn't continue, doesn't repeat. The AR generator, here this right one of the function generators, opens the gate of the LPG only once and only according to the attached shape and attached time, and that's it. I can rest my finger there to infinity. Nothing will happen. Let me use different shapes. Different shapes. Different times. And silence again. So this function generator, the right one, doesn't react to the level itself, to the level of the impulse at its trigger input itself, but to sharp rises. To prove that, at first I switch down again. Oh, that's too short. A little bit more. Yeah. To prove that, I change the patch and feed in the output here of the left function generator. I set it down. So I said the right function generator reacts to sharp rises and not to the level itself at its trigger input. And so I change the rise. Now we have no attack. Attack 0 is sent to the trigger input. Now I increase the attack. Still something. Still something. Still something. And now nothing. So at about the 1 o'clock position of the attack knob here, the rise is not sharp enough to rouse the right function generator. The right function generator doesn't generate any signal to open the gate of the LPG. I reduce attack a little bit, and once again we hear something. Both function generators shout their OK out to the world when they have finished their work, meaning they deliver a trigger impulse at their end trigger outputs. But both define finish work differently. Whereas the left AHR generator sends its end trigger impulse at once when the gate signal at its input falls back to 0 level, even if there is eventually a release phase going on, still going on. The right function generator, the AR generator, behaves a bit more patient and sends its end trigger impulse after finishing even the release phase. Let me demonstrate this. Once again, I patch the positive envelope out of the right, the AR, oh, it is already, generator to the level input of the dual LPG, of the left LPG. But I remove this. And by doing so, I have interrupted the connection between the standard, the default pre-patched left function generator to the LPG, so nothing happens when I touch the keyboard. And now I take the output, the trigger end of the left, the AHR function generator, and patch it to the trigger in of the left, of the right, left and right, of the right, the AR function generator. I hit a key and nothing happens because this generator, the AR generator, doesn't get any trigger input. Here it's still, the gate is still high, so the envelope generated by the left function generator is still in its active phase. And now let me even increase the release phase. When I lift my finger, then the AR function generator shall get the trigger impulse after the left function generator, the AHR function generator, will think that it has finished its work. And when I lift my finger and we get at once a tone, then, even if there is a release phase here, then the impulse, the end, trigger end, work end, OK, to the world is sent after the hold phase and not after the release phase. And it's the fact. When I hit a key, nothing happens. As long as I rest my finger, nothing happens. But at once after leaving the key alone, the AHR generator sends its end trigger impulse to the AR generator, which then opens the gate of the LPG, and we hear a tone at once after lifting the finger and not waiting until this quite long release phase, which I have adjusted here. Both function generators deliver not only the adjusted envelope at their plus outputs, but also an inverted version at their, well, at their minus outputs. Let me show what inverted minus really means. I take the inverted output of the left, I could do it with the right as well, of the left function generator and put it into the gate or level input of the left dual LPG, of the left LPG, and you will hear at once when I insert the patch cable here, we get a tone. Yeah, so we get sound. I reduce the volume a bit. We get sound as long as I don't touch a key, and when I do, the sound vanishes. This is inverted. Now, when there is a release phase adjusted, the sound slowly fades in instead of fade out. So let's wait. Now, yeah, once again. Yeah, I rest my finger. And when I adjust an attack phase, the sound slowly fades out and not in when I touch the key again. Without, with attack. My fingers are too thick. I remove it. Too thick for this small keyboard here. All right, this is the meaning of inverted, of the minus output of the envelope. Some words about patching the LPGs now. The diagram shows that the adjustments of the cutoff / level knob add to the signal, which eventually arrives at the level input. We know that the left LPG is part of the default, the pre-patched structure, but also the right LPG is pre-patched. Not its input, though. It is the output, which is pre-patched to the input of the space-out module. Both the left and the right LPG send their signals to the space-out. I can double a signal this way by inputting it to the right LPG while it by default and additionally is sent to the left LPG as well. Let me do so. So I take the carrier output of the source module and put it into the left patch point of here the right LPG, the signal input. So, and now the signal is sent to both by default to this LPG, and now I've patched it additionally there, where both should go to the space out module. But of course, I have to take care that the right LPG gets a gate, gets its gate opened as well. So I have to patch the envelope's output to the level. So now I close the left LPG completely. Nevertheless, we get a sound because it's patched to the right LPG as well. Now I close the right LPG, open the left one. All right. And now I open both. It clips after a while. If I need high filter cutoffs, and by that open the gate of the LPGs quite far. The signal gets not only loud but clips as we hear it. I should patch it through, let me reduce it a bit. I should patch one of the signals through the utility unit to attenuate it, but this is already a matter of the next part of part 5. But you see and hear that there are some interesting sound variants to gain by sending the same one and the same signal parallel to both LPGs, which then send their outputs to the space out unit. Perhaps a little reverb or a little space. Okay, no jamming around in this video. The modules space out and woggle, utility and split have already been sufficiently explained in this series, even in question of patching. The sequences module here needs an additional check though. The already mentioned node output, the rightmost patch point of the unit here, follows, according to the manual, a half volt per octave characteristic, 0.5 volt per octave. 1 volt per octave is more common in the world of synthesizers and modulars, and I want to control this characteristic therefore. And as one of my other series here on this channel is a diary of building a big modular synth on my own, I call it hardcore DIY. I've bought this nifty, you can see it perhaps, this nifty little handheld oscilloscope, which I'm going to use to control signals and voltages here at the Volca Modular now. So I put it in here so that you can see the display. This unit needs a ground at its black crocodile clip. I take it from the CV in. I could also take it from sync in or sync out. It's only about the ground, so I clip it to the ground. Yes. And the red one, there I feed the signal in, the node out here. And so I clip it to the red one. And I touch the C, the node C at key number 4. The voltage, corresponding to node C, lies now at the node out of the sequences unit. And as we see here, my handheld oscilloscope shows me that's DC voltage level, DC here, yeah, here, DC voltage level of 1.12 volt. It's here, 1.12 volt. Now, I hit or touch the key exactly 1 octave higher, and that one here, yeah, here it is, and the module tells me 1.5 volt. It's not completely half a volt higher. In some measurements, I did some before, it was exactly 0.5 volt higher. But we can say, yes, the Korg Volca Modular, the Korg Volca Modular, indeed follows so far half volt per octave characteristic. Let's try something else. Let's see. B. And 1 octave higher. Okay, it's not a huge difference. Right. I'm going to talk about this in more detail in part 6, because voltage levels and the range of minimum to maximum voltage at certain inputs and outputs are important things to know when I integrate the Volca Modular in my growing Eurorack system, and do some other things which shall be a surprise. There then I'm going to, there is going to be a lot more of measuring here with this machine, little nice machine. Surprisingly precise, by the way. I've done some measurements with other things, other electronic equipment to control. In this part 6, there's going to be a lot more of measuring and using this sweet handheld oscilloscope. It's talking about more electronics. Okay, well, let's proceed to the matter of how a system of setting up patches, of discovering a modular or semi-modular synth by patching may look like. Of course, there are several ways to approach patching, from just plugging in cables without thinking that much, to meticulously planning a complex patch before even touching any cable. Either way is okay. Either way will lead to interesting results sooner or later. But having a kind of system makes life easier. And so I'd like to show you the way I proceed. It's somewhere in the middle between being over meticulous on one side and just playing around on the other side. I say to myself, hey, it's all about modulating, about changing signals. So, what basically different kinds of relations between modules do exist? I've set up the following groups or situations. First, audio rate modulates audio rate, for example, in typical FM, PM, or amplitude modulation examples. Second, audio rate modulates sub-audio rate. Why shouldn't an audio oscillator modulate an LFO? Just an example. Third, audio rate modulates or determines non-repeating, non-oscillating signals and levels, ADSRs, for example, or certain stages of an envelope generator. Fourth, adding effects. No, that's clear. Fifth, adding or subtracting audio rate signals, also clear. Sixth, adding or subtracting sub-audio rate signals, including modulating sub-audio rate signals by sub-audio rate signals. One LFO modulating another one, or an envelope added to an LFO. Seventh, adding or subtracting non-repeating, non-oscillating signals and levels, for example, DC offsets, or non-repeating envelopes. And 8, adding randomness. Sure. 9, which is the reverse situation, the reverse of situation number 2, sub-audio rate modulates audio rate. Quite common situation. For example, an LFO modulates the frequency of an audio oscillator. And 10th is the reverse situation number 3. Non-repeating, non-oscillating signals and levels modulate or determine audio rate. For example, an ADSR or another kind of envelope generator determining the output of an audio oscillator or its frequency. And the last, 11th, all kinds of patching feedbacks. Well, I know it sounds complicated, but it's indeed quite easy. Just one more thing, and I'll show you how easy this system can work then. When I start using a new module, for example, here the Korg Volca Modular, I simply take each existing output, one after the other, and ask myself which are the patch points I can connect this output to, and which of the above-mentioned groups or situations would the resulting patch belong to. Why do you ask? Why do I ask myself this question? Well, Because each of the 11 kinds of combinations has their typical and characteristic behavior. For example, group 1, audio rate modulates audio rate. The result will always change the sound completely. Think of FM, PM, AM, and so on. The participating original audio rates, which is sounds, perish more often than not in the result. Or situation 6. Adding or subtracting sub-audio rate signals, including modulating sub-audio rate signals by sub-audio rate signals. There won't be any audible effect as long as I don't patch the result of this, let me say sub-patch, to anything else in my setup. But then I'll get something audible which has a quite complex sonic development in time. For example, one LFO modulating another LFO, and the outcome modulates, let's say, the frequency of an audio oscillator or the cutoff point of a filter. And so does each of the mentioned groups or situations have their specific kind of, well, let's say, predictability. Let me exercise this approach with my Volca Modular using two different outputs. First, the carrier's output in the source module. I've had an appointment at my dentist's, and I managed to survive this appointment, so my speech may sound a little bit different from normal. I hope it's nevertheless understandable. I get my new teeth next week, and I don't want you to wait longer than necessary, not because of missing teeth. So the inputs which are the nearest to the carrier output are the four inputs of the source module itself, which are from left to right pitch module, where I have patched the carrier's output in right now. Then the ratio output, the fold input, the fold input, and the modulation amount input. So I start, as you see, with the pitch input. And I know it's a feedback loop, what I have now. The pitch, the frequency of the carrier is fed back to the pitch input, which determines the pitch, the frequency of the carrier. But it's also frequency modulation at audio rate, and the ratio, the carrier to modulator ratio, is 1:1, I would tend to think at least, because it's one and the same oscillator modulating itself, one and the same frequency modulating itself, one and the same pitch modulating itself, right? Well, so what will prevail? The feedback characteristic of the FM characteristic with a 1:1 ratio. Let me hit a key on the keyboard to find out. Oops, neither nor, it seems. It's not like the 1:1 ratio FM that I get when the modulator modulates the carrier at 1:1. Let me show this. I remove this. And I have measured the frequency of carrier and modulator so that they are identical, so they are at 1:1. And now hitting a key and turning up the amount is really something else than what I get with the feedback. All right, it's nothing like feedback that I get when my microphone approaches my speaker either. So it doesn't sound like classical frequency modulation, and it doesn't sound like a feedback. Let me hit other keys. And oops again, the sound and the pitch are the same all over the keyboard. Well, let me explain what we have heard. First of all, the feedback of a microphone speaker couple is not at all the kind of feedback I've patched here. Let me do it. One of them again. Here. Because it concerns the volume, this microphone speaker couple, the volume, the amplitude of the audio signal. Here, it's all about frequency that is fed back. The next riddle that I want to crack is, Why is the pitch of the sound always the same, no matter which key on the keyboard I touch? Well, I take the LFO patch, just a moment, let me patch it. So, and I take its output and modulate the pitch with it. So, at first, far below audio rate. So, now I increase the frequency of the LFO. Once again back. What we see and hear, let me leave it alone. What we see and hear here is that the carrier's pitch changes between maximum and minimum, as expected, as I haven't attenuated the LFO's output. The LFO's modulation strength is always 100%, no matter which key I hit. And now increasing the frequency and reaching audio rate in the end leads to a spectrum which has its maximum there where the frequencies are most of the time. And that's neither the maximum nor the minimum, nor any keystroke, but somewhere in between at the point where the frequencies cross twice during a cycle, when they go up as well as when they go down. The exact position of this maximum depends on the shape of the LFO waves. Let me change the shape. Now it's nearly a downsaw, turning the knob more and more to the right until I get nearly an upsaw wave shape of the LFO. Alright, and that's somewhere in the middle, where it at least a bit resembles the triangle wave of the source module. But there is another important aspect which makes my feedback patch different from the LFO modulating the carrier's pitch. The voltage. It's again the voltage. The maximum output of the LFO is between 2.95 and 3.25. Let's look at it. Take my oscilloscope again. Yeah, now it's between 3.05 and 30 exactly, as we see here, the peak-to-peak voltage. But the carrier's output of the voltage is higher. So let me change this and go to the carrier's output. And now we see that the oscilloscope shows a higher peak-to-peak voltage, 3.6, 3.75, something like that. Occasionally it goes up to 4.35 and even to 4.45 volt peak-to-peak, as I have measured. And it doesn't matter whether I use a DC or an AC coupled mode. Let me change to AC. As you see, nothing happens. So it's the same amount of voltage. Yeah, you see that the modulation, the modulation strength by atom modulation by the carrier is higher than the modulation strength when I modulate using the LFO. I've adjusted carrier and modulator to the same frequency using my oscilloscope. I've done it earlier, and my ears, using my ears as well, and let me compare the carrier feedback loop with the carrier's output when modulated by the modulator. Normal way this device is meant to be used. So I don't need the oscillator now. First of all, I don't. Yes, I don't need this anymore. So let me hit a key. So this is what we had. And now I remove the patch cable and increase the modulation strength. Now the carrier is modulated by the modulator, by the internal modulator at the same 1-to-1 rate. Quite a difference. Well, we haven't thought about yet how frequency feedback works, in opposite to volume feedback. I take the LFO patch to analyze such a situation at lower frequencies, which are easier to observe. To do so, I patch the LFO's output to the split module. So, and lead one output to the default LPG, to the signals input, and the other output I connect, or I patch in the B input of the utility module, and from the utility module back to the time input of the LFO. So let me test it. All right. So now I change the amount of feedback with the knob in the utility module. I increase the feedback more and more, and back. And with different frequencies of the LFO. And comparing with and without feedback. Well, the feedback stabilizes a bit the frequencies in the spectrum, and what's interesting, the stronger the feedback, the lower gets the resulting frequency. The strength of the feedback in my primary feedback loop here was always 100%, always maximum. The resulting sound is quite low, is a quite low one, as we have heard. Well, let's make it again. Let's hear it again. Quite low frequency, overall frequency. Without going too deep into the theoretical aspects of FM, and not at all into its mathematics, let me simply say that the result of one audio range frequency modulating another one is a multiplication of partials of frequencies in the resulting spectrum. Each frequency in the spectrum of the modulator modulates each frequency in the spectrum of the carrier. And each of these modulations generate a whole bunch of additional frequencies. And all of these frequencies, the old ones as well as the newly generated ones, are fed back, and the modulation starts anew, but this time with a lot more of frequencies in the spectrum, a lot more of multiplications, creating a lot more of frequencies in the spectrum, which then are fed back again and again and again, and so on. No wonder that the result of our feedback loop sounds different, completely different from the result of a, let's say, normal frequency modulation at a ratio of 1:1. I know there are still a lot of whys and hows to answer, and a lot of them I answer in my series about frequency modulation and phase modulation here on this channel, and others I'm going to answer in future videos, not in this series about the Volca Modular though. So why not subscribing to my channel, and don't forget to click the bell symbol to get a message about every new video. But going deeper in two special problems of FM would exceed the matter of this series by far. Wow, what a long time talking about the outcome of one single patch cable. Please notice that the pitch input isn't only connected to the carrier's frequency, but also to the modulator's frequency. This means, at once, when we turn up the modulation amount, we hear the result of the carrier modulating itself and modulating the modulator, which then modulates the carrier. Wow! Which then, again, modulates itself and the modulator, which then modulates the carrier, and so on, and so on, and so on. Wow! Let's patch the carrier's output to the other three inputs of the source module now to find out about the sonic results, and let me go through it a bit faster this time. We must not forget that even the other three patch points here build a feedback loop when we patch the carrier's output to them. The output called carrier isn't the output of the individual carrier oscillator alone, but the main output of the whole source module, including all internal modulations, like modulator carrier FM, as in the last examples, or wave folding. All right, let's do some patching and find out about the sonic results. So at first I take the carrier output and patch it to the ratio input, but I increase, of course, the modulation amount to hear a result at all. All right, now I'm at the ratio 1:4, the lowest one, so the ratio can only get higher. I patch it to the ratio input. All right. Let me adjust the ratio of 1 to 2. Without any modulation. And now the feedback from the carrier's output to the ratio input with different modulation amounts. And different offset ratios. Now the ratio oscillates very fast in audio rate between a lower minimum 1:4 ratio and a higher 4:1 ratio, because I'm exactly in the middle. Let me try some space. not that. Seems a bit higher. Yeah, all right. And with lower offset ratios. At about 1:1, an interesting effect. Extreme modulation strength, and then I fade the modulation strength out. All right, let's try the next input, the fold input. Once again, at first without any, and then modulating the fold. Fold is pre-adjusted now here. The offset is 0, so it can only increase without space at first. And then, yeah. Now I choose a middle adjustment of the fold knob, so the offset is in the middle, so it can go lower and higher than adjusted here. Without, only fold, and now fold with carrier feedback, and a little bit space again. I slowly get used to this small, strangely colored keyboard. All right. Different fold amounts, or fold amount offsets to be precise. They don't change that much. Now I do something else. I don't feedback the signal directly, but I go through the utility unit, meaning I have the possibility to attenuate it. I'm still modulating the fold parameter, so I have to patch in the third patch point from the left. So this is without modulating the fold offset here, so at about 50%. I leave the space at the adjusted position, and now I fade the feedback, this feedback from here to here across the unit, the utility unit. I feed it in, fade it in. So what I'm doing here is fading in and out, now out. Not the wave folding itself, but the strength of the wave folding. There is always wave folding because I have adjusted this knob to about 50%. Let me try the same with no wave folding at all. No difference. Fading it in. It's a very sharp point where it starts, where it jumps in. There's no fading in. And then it's changing, of course, but not that dramatically. Let me put the reverb out. No, with reverb it's nicer. And now with maximum, maximum fold. Here I have attenuated it completely to 0, the feedback loop. Now it's maximum fold. Now I feed the feedback in. Yeah, I can feed it in softer. But increasing the feedback above about 50% doesn't make a difference anymore. Because modulating the fold amount can go only downwards because it's at maximum. It cannot be upwards and downwards as before when I was at 50%. Let me try the same. I go back to modulating the ratio. Now I'm modulating the ratio. Let's put the feedback down, the fold down, and let's use, without feedback at first, let's use a middle amount, and I go again to a ratio of 1 to 2, 1 to 2, and now I modulate this ratio at audio rate by the carrier's output, feeding the modulation in, the feedback in, what is modulating the modulation ratio. And back. The strength of the feedback, I'm reducing it now. No feedback, feedback, no feedback. All right, last thing. No, I leave that. I leave that attenuating patch here. Last thing to try is modulating the modulator with a carrier. This is a very interesting thing. So put it here in, because now the modulator modulates, of course, the carrier internally without any patching. And this modulating modulator is now modulated by the carrier, which is the target of the modulating by the modulator. Wow, okay. I think I'll insert a graph here in the video. All right, but let's listen to it. Once again, yeah, now we don't hear any feedback because it's at 0 here. And we have a quite moderate modulation strength here. One thing to make sure, when I said modulating the modulator, it's not modulating the frequency of the modulator, but it's modulating the modulation strength. Yeah, the modulation strength. All right, which is pre-adjusted at a moderate basic value. And now inserting or fading in the feedback loop. And fading it out. And now at another ratio. I'm not modulating the ratio anymore. Yeah, I'm modulating the modulation strength. But modulation strength offset, I reduce it a bit. Okay. And now feeding in the feedback, modulating the modulation strength. Without room, I with a bit of room here, a little bit less. Feeding it out, fading it out, and at maximum ratio 4:1, fading in the modulation, the feedback. Fading it out again. And let's say a middle ratio 3:1 is nice. Feed with feedback. Now with maximum feedback, all different, the whole spectrum of modulation, of modular to carrier ratios. All modulations and feedbacks in this video took place at audio rate. The results were rather rough and wild, harsh, often near to pure noise. This will not always be the case in the next video in this series. Well, thank you for watching for today. See you in part 5 with a lot more of patching, but only a bit less of explanations. Enjoy your day. Rolf.